So what have we done in this unit of trigonometry? We have done the 6 trig functions. We looked at trig identities. We looked at solving equations. We looked at the unit circle. We've done quite a bit. And I'd like for us to conclude the trigonometry section by looking at graphing sine waves. What do sine waves look like? How do I graph them? How do I manipulate them? How do I write the equations of them? So 3 days of notes on this concept, and we are done. So let's get this started. Please take out a fresh sheet of paper for some brand new notes. Let's call this sine graphs. So why don't we, right off the bat, go to Desmos to see what Desmos tells us about what sine functions tend to look like. So your basic sine wave takes this form. Y equals A times sine of B times x minus h close plus k. Let me activate all sliders. Let's go RCHS purple. Folks, you're looking at a sine wave. This is what a sine wave looks like. It's the same piece repeating over and over and over forever. Let's play slider A. What does A control? A controls what we call the amplitude. It controls sort of how tall it stretches like a slinky. It also controls the orientation, whether it goes up or whether it goes down. Let's pause A. Let's play just B, but B actually controls sort of the stretchiness side to side, whereas A controlled the stretchiness more up and down, if I can use loose vocabulary. What about H? H controls the side to side movement. See, it's frozen in terms of the stretchiness. It's just moving the entire assembly left and right. Now, as you can predict, K moves the entire assembly sort of up and down. So now that we've seen what these individual parameters control, let's take this information back to the board. Thank you, Desmos. Pencils up. A sine function can be modeled by y equals A times sine of B times x minus h, close both doors, plus k. Now we have to discuss what A, B, H, and K control. And the first one is amplitude, absolute value of A. And then we have phase shift, H, vertical shift, K, and period equaling 2 pi divided by the absolute value of B. Now, what about the orientation of the sine wave itself? There are 2 cases, and they are if A is positive, then your sine wave will go up, then down. If A is negative, the orientation is reversed. It goes down first, and then it comes up and comes back down. And regardless of the case, we have 5 points. You have the beginning and you have the end. And between beginning and end, you have a point in the middle. And between these two, you go up. Between these two, you go down. Same thing here. You have a beginning point and you have an end point. And in between them, you have this here. In between these, you go down. Between those, you go up. And then for both cases, what we can do is we can draw 3 dotted lines. They look like this, watch. So they look kind of like you have a line that goes down the middle, and then you have a line that goes through the top, and then you have a line that goes through the bottom. And same thing here. You have a line that goes through the top, and a line that goes through the bottom. So we have 3 lines, top, middle, bottom. So with all of this in mind, so please copy this while I ramble on. Now we do know that per Desmos, sine waves go on forever and ever and ever. And all I want for you to do is to give me just one complete cycle, one complete wavelength of this sine function. I think it would be a good idea if we made a shopping list of A, B, H, and K. I also threw in the period. We're going to need that. So let's go through and see what each one of these things is. What's A? A is -4. B is 1/3. H is negative pi fifths. H is the only one that you sort of do a switch upon. And what's K? K is 1. 1. Now, what's the period? The definition of the period is 2 pi over the absolute value of B. So this is 2 pi. Now, what's the absolute value of B? Well, B is 1/3. The absolute value of 1/3 is just 1/3. And this becomes 6 pi on your Casio calculators. Now, these pieces here, they are there for reference. We can use them for whatever we want. How am I actually going to graph this sine function? Look, I'm okay if we use Desmos to graph it for us. However, if you type this into Desmos, it's going to go on forever and ever and ever. And I don't want the whole thing. I only want one piece of it. Which specific piece do I want you to draw? This one here. That's why I think now would be a good time to discuss the domain or to write down the domain, and then we can type that into Desmos and you'll see how this works out. So I want my domain to be H. Now what's H? H is negative pi fifths. Less than or equal. X is just the variable. Less than or equal. H is the same number. And then we have addition. And now the period, what's the period? See, the period was 6 pi. That's why we did the period back there. Now, you know what? Before we type this in, can you tell me what this is, please? Type this into your devices. It'll be negative pi over 5, less than or equal to x, less than. If you type this in, that'll be 29 pi over 5. I think now we're ready. Let's go to Desmos. Let's type this in. And let's see how this helps us out. So let me type this into Desmos. Now notice that if I zoom out, that this sine wave goes on forever and ever and ever. And I don't want that, that's too much. I only want one piece of this. So what you can do is in the same box, give it a few tabs, doesn't really matter. Type in a curly brace and then type in the domain that we had on the board. It was negative pi over 5, less than equal to x, less than or equal to 29 pi over 5. Let me scoot this back a little bit. Notice that it no longer goes on forever. It just has one specific period, one specific wavelength. Now, I literally just want you guys to take like 5 seconds and sketch this. But it would also be nice if you were able to tell me the coordinates of the start and the end. Now, if I click on it, it's see how it does weird decimal? I don't want that. I want exact values for just the beginning and the end. So let's go back to the main board to discuss how to find the exact coordinates of the beginning and end. Just take 5 seconds to draw the graph that Desmos gave us. That's more or less what it looked like, yes? Now, before I let you go, it would be very nice of you to tell me the coordinates of the beginning and the end. Can we agree that the start and the end have the same y coordinate? And that y coordinate is going to be 1. It's always going to be whatever this is. So that's 1 there, and that's 1 here. Now, what's this x coordinate? Well, this x coordinate is where the domain begins. This number here. And this x coordinate is where the domain ends, 29 pi over 5. So guys, the coordinates for the start and the coordinates for the end, we can generalize this idea. And here is that idea. Your start point and your end point, they have coordinates. They have an x coordinate and they have a y coordinate. And these are the coordinates for both of them. Your start point will have coordinates h, comma, k. That hk is where you start. Now this point where you end, it's located at h plus period, comma, k. So these are the general coordinates for the start and end points of a sine wave that has a very restricted domain. So tomorrow we will add to this and extend these concepts, but for now, try the attached exit ticket. Ready, set, go.